Many people see Rajasthan as a single, unchanging landscape, an endless, scorched expanse of sand. The physical reality of the region tells a different story. Within its borders, lush, freezing mountain peaks exist alongside extreme droughts and sudden, violent floods. During the peak of summer, the atmosphere becomes volatile. The Lu brings skin-burning winds across the plains, often joined by babuya, tight, swirling dust devils that pull heat directly from the ground. Yet these events are occasionally interrupted by the dogda, brief pre-monsoon showers that provide a momentary reprieve from the sun. These individual events represent weather, the momentary changes we feel day to day. But when we look at the 30-year pattern of these recurring events, we see climate. These atmospheric shifts follow a rigid, invisible geographic logic. To understand the region, we have to look at the forces engineering these extremes. The baseline for this heat is the Tropic of Cancer. It cuts directly through the state's southern tip, exposing Dandapur and Banswara to direct overhead solar radiation, while the northern districts receive only slanted rays. This creates a thermal contradiction. If the south receives the most direct sun, it should be the hottest point in the state. Instead, the western district of Churu consistently records the most intense summer temperatures. The thermal properties of desert sand explain this shift. Churu's landscape absorbs heat rapidly during the day, driving thermometers to the state's highest peaks. At night, that same sand sheds heat just as quickly, making Churu the coldest district during the winter months. Contrast those shifting dunes with Mount Abu, where the air remains cold and misty while the rest of the state swelters. This is the result of altitude. For every 165 meters of elevation, the temperature drops by 1 degree Celsius. At 1,200 meters, Mount Abu exists as a separate climatic pocket where elevation overrides the solar heat of the surrounding plains. In Rajasthan, local factors like sand density and sheer height create a patchwork of temperature contrasts that defy simple latitude. A similar tension exists regarding the water supply. Massive, moisture-laden monsoon winds move in from the Arabian Sea every year, yet the western desert remains completely dry. Typically, a mountain range acts as a physical barrier. It forces air upward, causing it to cool, condense, and fall as rain. This topographical map shows the Aravalli mountain range, running diagonally across the state. The Arabian Sea winds travel perfectly parallel to this range. Because the mountains align with the wind rather than blocking it, the heavy clouds slide past without dropping their moisture. The very range that could have trapped the rain instead creates a smooth corridor for the clouds, leaving the western half of the state in a permanent rain shadow. Rajasthan receives its actual rainfall from the opposite direction. A secondary monsoon branch from the Bay of Bengal enters through the east, eventually meeting the Arabian branch in the south to provide the state's primary water source. During the winter, the Mawat provides essential moisture. These golden drops help rabi crops like wheat survive the dry season. The global map shows the origin of this water. This moisture and the intense winter cold are carried by western disturbances, winds traveling thousands of miles from the Mediterranean and Caspian seas. Standard maps based only on rainfall or heat fail to account for how a Mediterranean wind can dictate an Indian harvest. To make sense of these overlapping systems, researchers had to look past simple averages. Scientists like Koppen and Thornthwaite integrated temperature, precipitation, and evaporation rates to create a more precise model. They assigned the states specific categories, ranging from the arid BWHW zones to the tropical savanna conditions of the AW regions. This scientific language reflects a climate so complex that it requires a global perspective to accurately map. The data reveals the harsh reality of this geographic engine. Even with global wind systems, the state averages only 29 days of rain a year. In Jaisalmer's Som dunes, that average reaches 0. In Ganganagar, this lack of moisture results in 27 days of blinding dust storms annually, where visibility is frequently lost to the wind. The people here have adapted to these pressures, building a culture that moves in rhythm with the atmosphere. Survival depends on recognizing the specific winds. The Pourvai comes from the east, the Darao from the north, and the Samundari carries the scent of the Southwest Sea. In Rajasthan, geography dictates the timing of the harvest, the design of the home, and the limits of where life can take root. The climate is the silent force shaping every aspect of the region's history.